So today, guys, we are going to be using Pythagorean theorem to find the distance formula, meaning we're going to be finding the distance between 2 points. So how do I find the distance between 2 points? First, you are going to plot the 2 points on a graph. Then from those 2 points, you will draw a right triangle using those 2 points as your diagonal. And after we have a right triangle, we can use the Pythagorean theorem to find the missing length. So we're going to be using Pythagorean theorem here to draw triangles and find the missing length. And from there, we will be able to actually figure out what the distance formula is. So our first example is we want to find the distance between the 2 points -4, 1 and +4, 7. So what we're going to do first is graph both of these points. So let's graph -4, 1 first. Now, as a review of graphing, which number is the x coordinate? -4 or 1? Everybody? -4. Good. What's the y? 1. So along the x-axis, we are going to go to the left 4 spaces, 1, 2, 3, 4, and up 1 space. So your point should be here. Everybody agree? Mm-hmm. Okay, good. So then what I want you to do is graph on your own right now. I'll give you like 20 seconds. Graph the point 4, 7. So the point 4, 7 would be to the right 4 spaces, 1, 2, 3, 4, and up 7, 1, 2, 3, 4, 5, 6, 7. So your point should have been here. Do you guys agree? Yeah. Okay, good. So what our next step says, I'm going to go back really quick. Our next step says to draw a right triangle using those 2 points. So here's how you're going to do that. You are going to draw a line going from that blue point along the x all the way to where it meets the red point. So it should look like, that. So all the way to where it meets the purple point. And then from there you're going to draw a line up to the purple point. And then draw a line in between the 2 points. Oh my gosh, we made a triangle. This is a right triangle because, so you can draw the little right angle, because we went straight across and then straight up. So we made perpendicular lines. So we automatically know it's a right triangle. And now we can use Pythagorean theorem to find C. So let's label C because that's the part we don't know. Because it's going diagonal through the little grid points. So we can't just count the spaces. But we can count the spaces of the legs, right? So let's count the spaces of the legs. In between, from the blue point to where that line stops, I have 1, 2, 3, 4, 5, 6, 7, 8 spaces. So label that 8. And then going up to the purple point, that's 1, 2, 3, 4, 5, 6 spaces. So that one is 6. So our 2 legs are 8 and 6. Let's use the Pythagorean theorem to find the distance between those 2 points, which is C, our hypotenuse. So that's going to be 6 squared plus 8 squared equals C squared. 6 squared is what, ladies and gentlemen? 36 plus 64 equals C squared. What's 36 plus 64? 100. So 100 equals C squared. And then how do I get C by itself? Square root. So what's the square root of 100? 10. So C equals 10. So our distance between these 2 points is 10. Okay, so example 2, we're going to find the distance between 1, -5 and -4, +7. I want you guys to try this one on your own. So you can work with your neighbor or the people at your table, but I want you to do exactly what we did in example 1 with this guy. So to graph the points, let's first do 1, -5. What color do you guys want to graph 1, -5? Pink?
Yeah. Pink.
Okay, we'll do pink.
Yeah.
Okay, so 1, -5. That's going to be 1 and to the right 1, and where am I going to go from there? Down 5. So 1, 2, 3, 4, 5. So it should be right here. And then let's graph -4, 7. So that's going to be left 4, 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6, 7. So I should be right here. Everybody good so far? Okay, so then we have to make the triangle. So from my green, I'm going to go down all the way to where, that's not a very good line, all the way to where the pink was, and then across. And then we'll be able to make our triangle. This is like a long, skinny triangle. Okay, so, ladies and gentlemen, what was the distance of this leg down here?
5.
It was 5? 5? 1, 2, 3, 4. I got 5. 1, 2, 3, 4, 5. Yeah. Okay, and what was the distance of the tall one? 12. You guys all agree? Okay, so to plug this in, oh, I forgot to make this a right angle. To plug this in to Pythagorean theorem, let's label the hypotenuse C. That's going to give me 12 squared plus 5 squared equals C squared. Guys, what's 12 squared? 144 plus 25 equals C squared. What's 144 plus 25? 169. So 169 equals C squared. And then what do we do? You square root, and then you get C equals 13. Good. How do you guys feel about this? Thumbs up, thumbs down? Thumbs up, you're awesome. Thumbs down, still don't get it.
I think this is working.
This is your smart water is working. Okay, so what do you guys notice about finding the lengths of my legs? I'm looking here just at the lengths of the legs. Let's look at the x's first. So the 1 and the -4. What do you guys notice about 1 and -4 in terms of what we got as our leg length?
You add them both, but you have to make it positive.
You add them both, so that makes it positive. So were we really adding them both?
Nope.
No? What were we doing?
Counting the distance between.
You're counting the distance between the two. So if I'm adding a 1 and a -4, but that -4 becomes positive, what are you actually doing, Andrew?
Adding the absolute value.
Adding the absolute value? Not quite. Multiplying? Times a -1. Guys, what happens when you subtract a negative?
It becomes positive.
It becomes positive. So look at this. The x is 1 minus -4. What does that become? 1 plus 4, which it gives us 5. So going with this subtraction thing, now look at the -5 and the 7. What would be -5 minus 7?
12.
-12, right? But if we're looking at distance, you can change it to a positive, right? Absolute value. So if we subtract the x's and subtract the y's, that's going to give us our lengths, right? Yes, you guys agree? That's the distance formula. Okay? So basically it's Pythagorean theorem. We subtracted the x's, and then we squared it here, 5 squared. And then we subtracted the y's, and we squared it. And then after we added them together, what do we have to do? take the square root. So, distance formula. The distance formula, D equals the square root, because that's what we have to do at the end, of the first x, or x2 minus x1. It doesn't matter which x you use first, but you square them, which makes it positive, plus y2 minus y1, and then you square it, which makes it positive. The only thing I need to draw your attention to is, what do you guys notice about the x1, x2, y1, and y2? About the order of things. I have to put x2 first. Whichever x you use first, you have to use that y first, okay? So it's like finding the slope. Whichever x you use first, you have to use that y first. It has to go in the same order. So write the distance formula out, and then we will do this example together. So let's do example 3 together. We're going to do the y's in purple. Okay, so we want to find the distance between -2, 7 and -3, -7. So let's write it all out. First, distance equals, make a nice big square root. What I always like to do is I like to label the points. So what would be my x1? Good, -2, which would make 7 my y1. So the little number next to the x and the y just tells you which point it is. So the ones mean that this is the first point. So that means that my x2 and y2 are going to be -3, -7. So just the 2 means that this is the second point. The 1s mean that that's the first point, okay? The important thing, and why I have you label them at first, is because notice, here I have x2 first, and then when I get into my y's, I have y2 first. So you have to use the same point first when you're subtracting. Okay, so let's plug it all in. So x2 minus x1, which one is x2? -3 minus x1, which is -2, so make sure you put it in parentheses, squared, plus okay, guys, so if -3 is my x1, my x2, what's my y2? -7. So -7 minus, what's y1? Why? 7? Squared. Okay, so order of operations tells us that we have to do inside parentheses first, correct? So let's take a look at inside both of our parentheses. So this is going to be distance equals, make your big square root again. Okay, guys, -3 minus -2. I have minus and negative, so what happens there? It all turns positive. So what's -3 plus 2? -1. So put it in parentheses, -1 squared plus -7 minus 7. What's that give me? -14 squared. Oops. If it came out to 0, it would have had to be -7 plus 7. Because this 7 has a minus in front of it, that 7 is actually negative. The sign in front is attached to the number behind it. So this is -7 and -7, which gives us -14. All right, so then we're going to have distance equals the square root. What's -1 squared? Negative 1 times negative 1. Positive 1 plus, what's negative 14 squared? Negative 14 times negative 14. 196. Okay. We're almost there. So then your distance equals the square root of 197. So can we break that down? Can we break down 197? So I think 197 is prime, so you actually would just leave your answer as the square root of 197, and that's totally acceptable. Okay, guys, so last one. I want you to find the distance between 1, 2, and negative 3, negative 4. What I want you to do right now is just plug everything into the distance formula, and then we'll stop and checkpoint to make sure that everyone plugged it in correctly, and then I'll give you the rest of the time. So first, what is my x1, y1? Which point do you want to make x1, y1? What's x1? The 1. What's y1? 2. So then what would x2 be? Negative 3. And what would y2 be? Negative 4. So 1, 2 is your first point. That's why it has the 1s. And I just labeled x and y. Negative 3, negative 4 is the second point, which is why it has the 2s. And I labeled x and y. So what I want you guys to do is plug it into the distance formula. Do not solve yet. So to plug it into the distance formula, guys, I have d equals and a big square root. Minus and then squared plus minus squared. Okay, what did you plug in? What did you plug in here? It should be x2. So what'd you plug in there? Negative 3. Which means we have to plug the other x into this blank spot. So what goes here? 1. So negative 3 minus 1. That's our first one. Now because I use negative 3 first here, I have to use the corresponding y first. So what did you plug into the next blank? Good, negative 4. Which means what goes into the last blank? 2. It's not a negative 2, it's just a 2, but it is being subtracted. So now what I want to do is let's finish all of the work. So d equals the square root. Negative 3 minus 1 gives me negative 4 squared, plus negative 4 minus 2 gives me negative 6 squared. So d equals the square root of 16 plus 36. So d equals the square root of 52. And let's see if we can break down 52. 52 is 2 and 21? No, not 21. 26. 26 is 13 and 2. So do you guys see a pair? 2's. So pull out the 2's. So the distance equals 2, and what stays inside the square root? 13. And that's your answer.